Last time we looked at trigonometric functions and composite functions. This evening we're going to look at the exponential and logarithmic functions. It's not turned on. There we go. Derivative of e to the x is e to the x. This is the natural exponential function. Right? Or the general rule, derivative of e to the gx, e to the gx times g prime of x. Again, I'll let you read through the derivation in the textbook. The derivative of natural log of x is 1 over x. More generally speaking, the derivative of the natural log of g of x is g prime of x over x, or sorry, g prime of x over g of x.
Could you go back to the logarithmic, to the time?
All right, so that is the natural exponential, right, and the natural logarithmic. More generally, derivative of log base b of x is 1 over x natural log of b. I'm actually going to skip ahead just to the general rule where we use the chain rule. Derivative of log base b g of x, g prime of x divided by g of x log of b. And for the general exponential, derivative b to the g of x, b to the g of x times g prime of x times natural log of b. It's easy.
Easy, yes.
Look at that. Real simple. 5 to the x. It's the function times natural log of base. So you want to identify what type of function. Natural exponential, right? That rule says e to your function times the derivative of the function. Three e to the 3x minus 1. Again, identify the function. This is a general exponential. What is the base? 7 to the 2x squared plus 1, natural log of 7, times the derivative of the power 4x. So I'll write it that way, I guess. Identify the function. It's a natural log. One over 3x squared plus 1 times the derivative of 3x squared plus 1. What kind of function are we dealing with? Product. What was the product rule?
First d second plus second d first.
What is the derivative of x? It's 1, right? Now, derivative of e to the 2x.
2e to 2x.
It'd be e to the 2x times the derivative of 2x. Right, that's e to the 2x times x plus 1. So identify the type of function. This is the quotient. What is the quotient rule?
Well, b high minus high b low minus low. Thank you for that. It's difficult to remember.
So x squared times Derivative of log of x.
Oh, over X.
Just 1 over x, right? Minus derivative of x squared. Over x squared squared.
Oh, you can factor that in.
Mhm. There's the derivative. Equation of the tangent line at the point x equals 1. Well, first thing we need, y prime, right? What kind of function is it? So what does the rule tell us? Not exactly the same exact.
Well, then you need to change.
Yes.
Oh, yeah, I forgot. You always make the change for check.
Right, and then, so it's e to the power, then what?
Minus 2x. Times 1, so.
Times negative 2x, right? Okay, that when x is equal to 1, what is e to the minus 1?
1 over 8.
So we get a slope of 2 over e. What is y at x equals 1?
E.
No, the E is a negative 1.
Which is what?
1 over E.
But negative 1 squared is.
It's not negative 1 squared though, is it?
Oh, I'm sorry.
It's negative x squared, right? Minus 2 over e, which equals negative 1 over e. Here's our tangent line. Y equals 2 over e times x minus 1 over e times that, just 1 over e. Yes.
So like, there's like the natural, exponential, and logarithmic rules, but then there's like it for like any constant in them.
Mhm.
What if it's like a variable or a function, like x to the x?
That is not an exponential. Right, exponential is a constant to a function.
Do we know the tools to make?
Not yet. We will be looking at those. We can't do it just yet.
That's cool.
Just give me the data problems. Thank you. Oh, yes. So let's look at several of these. What kind of function are we dealing with? For the first function, what kind of function is it? Right. And what was that rule?
Space and times the five, or times the five values on rectangle.
What's the derivative of multiplying by?
That's
6 x minus 4.
That's just the first term of the product rule, right? Plus that second function is what?
Sine,
What does the sine rule tell us?
negative, cosine, cosine, and then the chain rule. So it's just
Let's simplify where we can factor out an e, right? And we're going to be left with factor out the 2. Would it be beneficial to go any further? I don't think so. Sometimes we just leave it like that. What kind of function are we dealing with?
Natural log.
What does the rule say?
It's 1 over the inside function times the derivative of the inside function.
When you go to take the derivative of that function, what are you going to have to use?
Quotient rule.
You can do that. That's perfectly fine.
Um,
How else could we proceed?
Oh, is it natural log of natural log of the natural log?
Wait, would it be like the natural log of the numerator minus the natural log of the denominator? No, wait, log rules? I didn't remember those.
Isn't that much easier to take the derivative of? Work smart, not hard. One of the number one laws of the universe. Everything must be in the lowest energy state. Another way of saying that is the universe is lazy. It's in our nature, so embrace it. Also, entropy. So don't bother cleaning your house because it's going to get messy again. The universe is chaotic by nature. First log. What is its derivative?
2x over x squared plus 1.
Let's see.
That's it. What about the second one?
Two over 1 minus x over 2 minus x. 2 on top divided by 1 minus 2x.
What's the derivative of 1 minus 2x?
Oh.
Negative 2.
Negative 2. Common denominator. We're going to have just write out that, right? Let's simplify it. We have 2x squared. Not, of course, it has to be negative, so that's going to be last. 2. Oh, okay. Plus 2x. Then negative 4x squared plus 2x squared is minus 2x squared. Oh, that's nice. Over. Is that really worth me expanding out? Probably not. Can x squared? No, x squared minus x minus 1 does not factor. Bummer. There we go. And I leave you to verify that if you don't rewrite the log first, that you get the same thing. With probably a lot more algebra. what's going on. Right, that didn't work. No idea what's going on. What kind of function is this? Hmm?
Like a power function.
This is a powered function. By the way, another way that you might see it. Same notations with the trig functions. What does the power rule tell us?
Bring the 4 down, subtract it by 1.
But now, what was being raised to a power?
Natural log
So what does that rule tell us?
is bomb. The bomb is a function in the chain rule. Chain rule is bomb.
Which is what?
5.
Like that? Looks good. Okay, really, ruler, what's going on? No, it shouldn't be what is going on with PowerPoint right now. It should be doing that. I have to restart PowerPoint. Lovely. Don't know what was going on there. What's the function? So what rule?
Product rule.
Tells us what?
First T second, but second T first.
Yeah, I use the other order. The order doesn't matter, I'm just going to stick with the other order.
Second T first is first T second.
The order doesn't matter because it's sum, but I like to keep it in line with the quotient rule,
Oh, okay.
right? Because it's quotient rule is gf prime minus fg prime, so I try to keep it the same, gf prime plus fg prime, but it doesn't matter. So second function, 3 cosine of x. What's the derivative of the first? Plus first times what kind of function is the second function?
Negative
It's not logarithmic.
Exponential.
What kind of exponential?
Post-exponential?
What's the base?
Integer.
What's the base of our exponential? 3. It's an exponential base 3 function. What does the general exponential rule tell us?
Prime of G ln of base. Prime of cosine x times ln natural log of 3.
You're missing something. This is. Oh, okay, this is important. Ask me what I want from Chick-fil-A. That is definitely important. Sorry, this is.
Can I give it a shot for the derivative of that part? It's the base 3 to the power of cos 3 of x.
So that's what you're missing.
Times the derivative of cos x, which is negative sine x, times ln of 3.
I'm going to keep it in this order for now, just to separate the chain rule out.
Okay.
Right, because this is the rule itself. Right, and then chain rule says multiply by the derivative. But the order doesn't. Now let's just simplify it. Could factor out an x, but is that going to benefit me in any way? Oops, minus x squared log of 3 times x all times 3. Oh, I could have factored out that 3 to the cosine x, huh? Oops. No, whatever. Sorry, took an extra line. Right. Now, if you really want to get fancy, there is something else we can do. Aside from factoring out an x, which I'm not going to do. Could use laws of logs. Now, I will say be careful, especially when you're handwriting. Even if I kind of do something like that. Is that 3 times cosine or 3 to the cosine?
It looks a little muddy.
Yeah. I have no idea.
Experiment, that's compact.
And I'm not going to give you the benefit of the doubt on a test. So be careful how you write it. Make sure it's clear that's an exponent. Are you serious? What's the point of the roller if it freaking resets every time?
Is there a straight line tool for Photoshop? Or not Photoshop, PowerPoint?
So what we have to do is something like this, and it looks like we're going to have to use lasso. I think the shape should turn that into a straight line, but of course, PowerPoint is being stupid. And bringing this up, I have no idea what the hell this is.
How the word want to do with it?
Go away.
Can you copy the straight line you already made?
How do I delete? Cut. Copy.
Oh.
I was trying to be nice PowerPoint, but you want to be a word I can't say. It's not polite to say in public. Actually, I guess it is, because it is just a title term. It's also someone's name. It's also a certain appendage. It begins with D. I'll let you fill in the rest.
Oh, I was trying to do it. Or is the store, sports store.
It is a sporting store too, yes.
Sports store.
You have to actually, so math is actually very dangerous for people with dirty minds. Because what's the derivative operator is just a capital D. Guess we use a lot in differential equations.
Why does it keep getting dark?
Because I'm screenshotting.
Oh.
You want to adjust the size. Something's going on with my computer.
How the Windows up there or something.
Yeah, but I already had to reinstall Windows once on this. I don't have to do it again. Thankfully, it wasn't a clean install. That pissed me off. It was just let's just repair it by reinstalling Windows Update, and that fixed the issue. It was nice. What kind of function are we dealing with?
Okay, I know it's a quotient function, but it would be easier if we did X for the concrete.
Too bad. It's a quotient. Gonna force you to use quotient on here.
You said we're smarter than
Do as I say, not as I do.
Got it.
right? So in this case, I'm going to say you have to use quotient rule.
What behind like how you want to square?
Kind of function is the numerator.
Natural exponential.
What is the rule?
Right. Take the same question rule.
What kind of function is the power?
Okay,
What's the tangent rule?
secant squared.
No, this one's difficult. What's the derivative of the denominator?
3x squared.
What's x cubed squared?
X to the sixth.
Now let's simplify. I guess I could factor out that tangent as well. So common form you might see a lot is this. For some reason. I really don't know what the difference between that is and just putting everything in the numerator. I don't know, but I do see that form a lot. So I'm just pointing it out. Oh. So what kind of function is that? What does the natural log rule tell us?
1 over the inside function times the derivative of the inside function. Or is it derivative of the inside function over the inside?
Yeah, same thing.
Score.
I'm going to use the latter. So take the derivative of the inside, what is it? Right, so that's what kind of function is inside. What's the sum rule?
Derivative of the sum of the derivative.
Right. What's the first term?
Sine squared.
What kind of function is that? Power function, what does the power rule say?
Burn down to 2, burn down 2 subtracted by 1.
Times.
Times chain rule. Oh,
Which is, so what would the chain rule give us?
cosine.
Good. What's the second function?
Well, natural.
Natural, right? Yeah, it's the e function. Which tells us what? What's that rule?
This is
It's itself times chain rule. Times
E to the x never changes.
yeah.
Well, it does technically change. And it changes e to the x, but we can take the strip, it's just the same thing. Happy with that? Too bad. I'm not.
double angle formula on the top.
So what do you get when you use double angle?
Your sine of 2x over 2. Because it's just a 1 as the coefficient.
Is there one as a coefficient?
Well, I think that's a 1. Is that a D?
No.
That's a 2.
That's a 2. Oh, I'm sorry. Oh, yeah. Just sine of 2x then. No, I like your handwriting. Good handwriting.
It's October 9th, and someone finally complained about my handwriting.
It's good. It's good. It's good.
This is, by the way, why I stopped writing on the board. Getting your handwriting nice on board is terrible.
Can you cancel ABS or
No,
no? No.
because it's a sum. And there's not an EBX common in the other two. So we're going to leave it like that. Well, that was boring. I'll skip that one because that one's boring. This one's more interesting. What kind of function are we dealing with?
Tangent,
What's the tangent rule?
secant squared, tangent.
What kind of function are we now dealing with?
The sum.
What rule?
If we sum some rule.
Right, so it's sum rule, right?
Yeah.
Now, what is the first function that we're going to be dealing with?
E
What is the exponential rule?
two,
Go ahead.
2 e to the 2x,
What is the second function we're dealing with?
natural log.
What's the natural log rule?
It's derivative on top and whatever it is on the bottom.
For the sake of making it look nice, I'm going to use a negative exponent for now. Now we have to simplify.
Can you take out 2?
You can. We're still going to be left with, unfortunately, a sum, which is annoying. I think what I'll do is do it this way. Move it down, unfortunately. I don't think there's anything else we can do, is there? No, nothing beneficial. Oh, yes. What kind of function is this?
Quotient.
So what rule do we have to use? What rule? What does the quotient rule say?
Numerator, denominator upon minus,
You mixed up the order.
denominator times numerator upon minus the denominator, numerator upon all divided by the denominator squared.
So look at the numerator. What kind of function is it?
Natural log
What's the rule?
1, from the top divided by whatever's inside,
And so what is the derivative of what we're taking the log of?
2x.
Look at the denominator. What kind of function is it? So what's the rule that we use?
Second prime first plus first prime second.
That? Oh, there's an e to the x common. Let's get to that right now. Now I have to clear out that complex fraction, the compound fraction. So room, bummer. And I am actually going to simplify that further, I think. That's going to stay the same. I'm going to use one of the log laws here. And I'll write the cosine out in front. Say that's the derivative. Oh, wait a minute. No, it's not. Wait a minute. Yes, it is. Well, there's actually something I could do. That's fine, but there is something else I can do. I think I am going to do it.
Is it that 1 plus that square or no? Because it needs something.
This going to factor out a cosine and cancel one in the denominator. This will be 2x minus 1 minus. Now, when you factor a cosine out of sine, what are you left with? Tangent. Well, you know what? I'm going to do something else too. I'll say I factored out a negative cosine x. So I can switch the order and make it a plus instead of a minus. That is just preference. I don't like negatives. So I think it looks a lot nicer with a plus instead of a minus. There you go. Now, is there anything else I can do? I don't think so. I think that is it, man. Unless I wanted to move the cosine up to the numerator as a secant, but that actually doesn't really change anything. I think it would make it worse. Good enough. Questions on the exponential logarithmic? Yes.
This is probably answered in the book where you said it's like actually derived. But I'm just wondering, like, so like e to the x, the derivative of e to the x is just e to the x.
Mhm.
The derivative of n to the x is just e to the x times the constant multiple of ln of
N to the x
Yeah.
would be n to the x log of n.
Oh, wait. Oh, okay, so it's not like a constant times log.
No, it's just b to the x. So b, the derivative of b to the x is b to the x log of a.
Okay.
That one, okay, so for that derivation, you may have to be a little bit careful. Because I think they use implicit differentiation, which I haven't covered yet. Implicit is section 3.8. Exponentials and logarithmics are 3.9. I just like to group all of the functions together first. Right, so I like to kind of follow the order of pre-calc. You learn about sums and differences and products and quotients first. Right, then I would actually really like to do exponential and logarithmics next. Because that's, or then you learn compositions, which is chain rule. Right, then you learn exponential and logarithmics, then you learn trigonometric, and then after that you learn inverse trigonometric. Right, so I like to try and stick to that order when we do derivatives, which is why I don't do implicit before exponential and logarithmic. Don't worry, we'll get there. That's next week. Speaking of which, that does only leave one function type left, right? The inverse trigonometric functions.
Oh, so x to the x is also implicit.
Yes and yes. So the technique requires logarithmic differentiation, which requires implicit differentiation.
Okay. Wait, what kind of function is that?
I don't know what its name is.
I feel like it would be a transcendental function.
Well, e to the x is transcendental. Transcendental is just a category. Right, so e to the x is transcendental, log of x is transcendental.
X to the x?
That would probably be transcendental, but I don't know if that has a special name outside of that.
Okay.
Also, we have to look at, I'm going to just do a real Good enough for government work. What's the equation of a circle of radius r?
R squared. Wait, what would be the equation of the area?
No, just of the circle. What's the equation of the circle?
Oh, pi r squared.
That's area.
X squared plus y squared plus r squared.
That's a special circle. That's if it's something at the origin.
X minus h squared plus y minus k squared equals r squared. Oh, you say,
Same thing.
You should use box and triangle.
Is that a function?
Yes.
No.
No, that's not a function. But I'm still finding tangent line of it. What we say is this implicitly defines y as a function of x. Well, what's slope of a tangent line? dy dx. That is implicit differentiation. Another cool type of shape is, I don't remember what it's called. I actually drew it right. But again, good enough for government work. Something like that. It's a box, but it's a dime, but instead of the lines being straight, they're curved in. That is also not a function. But we want to examine it. Now really, when I say examine, I just mean look for the slope. Because you will examine these types of things way more in depth in Calc 2. When you study geometry of the plane.
Which is in 4 cusps.
So obviously the derivative at those 4 points does not exist, but it does exist everywhere else. And like I said, you'll study all that way more in depth in Calc 2, right? So you'll actually be able to determine what the perimeter of that is from Calc 2, in Calc 2. You'll do a new derivation for the perimeter of a circle in Calc 2. Right? So you know what the perimeter is, right? Circumference, 2 pi r. You can actually derive that using calculus.
It's also like derivative of the area.
It happens to work out that way, but that I think is just coincidence. It's an integral. You do arc length, which is an integral. And again, that's all later. But the idea is right now we want to be able to determine slope at points, and that is implicit differentiation. And by the way, I also typically use implicit differentiation to derive the inverse trigonometric derivatives. But you can also do it using the formula for the derivative of an inverse function, which is what your project is. So you can do it one of 2 ways. I forget the midterm is next Thursday. We also happen to finish up with derivatives on Tuesday. I think I did mention that. But I'm not making the Unit 2 test next week. It'll be I think I have it set to go live the following week. So it'll go up, because I make the modules available the Thursday before the week starts. So they'll go up next Thursday, but it won't actually be set to be due until the following Tuesday. just so you don't have the midterm and the test at the same time.
And the midterm is on limits and derivatives.
Yes, everything we've done up to and including Tuesday, next Tuesday.
I also just wrote the third project.
How many do we have in total for group assignments?
I think I'm gonna do 4.
Okay.
The third project is coding.
Oh,
Not the coding like project 1, we're just actually do, no, this is like actual coding, using while loops and stuff.
What program did they replace?
I'm gonna require useful from, but I'm gonna show it off in class. And I'm thinking the fourth project, I might also do coding. I haven't decided yet. I'm thinking the third project is Newton's method for finding roots. Fourth project, I'm thinking about doing area approximations. So numerically finding area of regions, which is using Riemann sums, which I'll require as coding, which is iterations. I haven't decided on that one yet, though. But kind of shows off the power of computing. And if you're a STEM major, you are going to have to know how to code. No matter what STEM field you're in, I promise you're going to wind up coding at some point.
Not if I do botany.
Hmm?
I'm about to pivot to botany.
What's that?
Plant studies.
No, I promise you're going to be coding in that
No.
too. I promise you will.
No.
But it's gonna be coding with probably what time for giving water and food.
I promise you will.
I know I have to
I'm
go.
gonna pivot.
I know I have to do.
If you don't want to code, just get out of STEM.
That's pretty
Okay. Is that easy?
I already know I wanna go to code, but it's completely different language. I wanna go straight to deep.
So you can use the rest of this time to either work on the project or this worksheet.
Project.